Now we have our last but not least speaker, Antanas Šepikas, our freshly baked technical team lead of Node.js. And he is quite an experienced guy, has more than 9 years of experience in Node under his belt. He is, I would say, pretty cutting-edge personality, and we'll see that in his presentation about decorators and the TS39 proposal for Node.js language. So give a warm round of applause for Antanas Šepikas, and the stage is yours, Antanas.
Hello everyone. Hello everyone here. Hello everyone watching remotely. Yeah, my name is Antanas. I've been working in the industry for over 9 years. I've been working with Node.js on and off. I actually started working with Node.js when it was just recently released. I think it was like version 1.0.4 or something like that. But yeah, so anyway, it's getting late, and without any further delay, let's get started. Before I begin, I want to point out a couple of things. Even though I will be showing examples in TypeScript, and it might be obvious for some, but decorators are not TypeScript-specific feature. It's JavaScript-specific feature, and yeah, you do need since it's not yet released and it's a proposal feature, you do need a transpiler like TypeScript or Babel to use it today. So yeah. And another interesting thing about decorators, that something similar to decorators actually exists in other programming languages as well. For example, PHP have annotations, and actually since PHP 8 it was renamed to attributes. Java have annotations as well. Python has something which is also called decorators, which serve a similar purpose. C# and Rust have attributes as well. Even these things are called differently. They have different APIs and work slightly differently. They serve the similar purpose, which I will try to explain. Anyway, actually, and yeah, and some of these languages like JavaScript didn't have them right from the beginning. For example, Java, I think, got annotations since version 1.5 or something like that. Yeah, so okay, now that I got that out of the way, let's talk about decorators in JavaScript and TypeScript. First of all, what is a decorator? A decorator is a form of a higher order function, which is a function that takes a function as an argument and returns a function. But if that would be only the case, you could use decorators only with functions. And that's not the case in the JavaScript. You use decorators with classes and class properties, class methods, etc. So yeah, but as I mentioned, and I will repeat myself probably a couple of times, decorators are just functions. And it's easy to understand, well, it's important to know that it's just a function, because at first it might look a little bit intimidating, but if you think about them as just functions, it gets easier to understand. So simply put, decorator is just a function that wraps a piece of code and adds additional information or modifies the behavior of that code. Right. In JavaScript, decorators have special syntax. They are declared as functions, but you also can declare them as factory functions. The difference between the two is quite obvious. The factory functions accepts additional arguments that later can be used in the decorator logic. And also, you call decorators by prefixing them with @ sign, and you write them above the code that you want to decorate. Yeah, and also another thing to point out is that factory decorator approach requires you to add parentheses. That's actually something that I prefer to use because it implies that it's just a function. So now that we know what decorators are, the question is, what can we do with them? And it's a complicated question. There are many use cases, and you can think of your own use cases. Anyway, in JavaScript and TypeScript, decorators allow adding additional information about the code, and in some cases, replacing the behavior, or actually adding the behavior, modifying the behavior, or replacing the behavior of a code. And I also could compare decorators to object-oriented decorator pattern, but the difference between the object-oriented decorator, object-oriented decorator pattern and decorator as a language feature is that in the object-oriented pattern, you decorate object instances. And in case of decorators, you decorate classes themselves and add additional behavior, add behavior dynamically to them on class level. To further understand what can you do with decorators, you need to know that there are several types of decorators in JavaScript and TypeScript, and they have different capabilities. First, there's a property decorator, which is used to decorate a class property, and it allows observing and adding additional information about that property. Then there's Accessor Decorator, which is used to decorate a class property getter or setter. And similar to property decorator, it also allows observing and adding additional information, and it actually allows modifying the behavior of a getter and setter. After that, there's a parameter decorator, which is used to decorate class method parameters. And once again, it allows observing and adding additional information about that parameter. There are slight differences between JavaScript and TypeScript decorators, and this is one of those differences. JavaScript doesn't have parameter decorators available today, and to use them, you need to use TypeScript. But spoiler alert, that might change in the future. Then there's a method decorator. Personally, a method decorator is the most interesting decorator from my point of view because it not only allows adding additional information about a method, but it also allows modifying the behavior of that method. And lastly, lastly, there's a class decorator, which primarily is used to associate metadata, and well, it can be used to modify behavior of class, but mostly it's used to add additional information about that class. And you probably noticed that I was naming these types in a sort of weird order, and that was intentional because that would be the actual order of how decorators would be executed in the runtime. And I've copied this example, this actually quote from official TypeScript documentation page, and it tries to explain the sequence of decorator execution. And it also mentions that you also can decorate static properties and methods, and they would be actually executed after the instance properties and methods. And the class decorator will always be executed last. There are a couple of things that I still need to mention about decorators. One of those last things is about types. And the decorator is not tied to the context that it's decorating. So you don't necessarily have to use different decorators for properties and methods. You can write universal decorator that will work on either property or method. But the difference will be the arguments that the decorator function receive. So you could write something that checks what kind of arguments the decorator function are receiving and base your logic on that. And I've already mentioned that decorators in some cases allow modifying behavior of code. And this is achieved with property descriptors. And what is a property descriptor? A property descriptor is a JavaScript object which is associated to every single property of an object. And there are two types of property descriptors, a data property descriptor and accessor property descriptor. The difference between the two is that the accessor descriptor would be available for the getters and setters of an object. Yeah, so simply put, property descriptor is an object that is associated with every single property of an object, and it allows you to inspect and modify behavior of that property. Last thing about decorator types is that you can actually compose decorators, and you can use them. You can use multiple decorators on the same class, same property, same method, and they would be executed top to bottom, but the logic would be evaluated bottom to top. So that's similar to function composition in math. So hopefully by now you have a rough idea what decorators are and what can you do with them. The key points that you should understand about decorators are that it's JavaScript feature first. You can use them today, but you do need a transpiler like TypeScript or Babel. They are similar to annotations and attributes in other programming languages. They are just functions, and they also can be declared as factory functions. They are called with a special @assign prefix and can be used to associate information and modify the behavior of a code. They can be used on classes and class members. And lastly, they receive different arguments based on the context that they decorate. I will now go deeper into each type of decorators and will show you a couple of examples. Let's start from the class decorator. Class decorator receives a single argument, which is a class reference. And a class decorator, as already mentioned, can be used to associate additional information, which is called metadata, about that class and actually modify the behavior of that class. And let's look how we could do that. For example, I created a decorator which decorates a class, and it receives a class reference, and it returns an extended version of that class with additional log tag property. So you can imagine that you can dynamically modify classes like this. However, there's a slight issue with this example, and that's due to how TypeScript works. Since the property is added dynamically, a TypeScript compiler would not be able to see it. You can work around it by casting to any type, but keep that in mind. And that would not be the case in JavaScript, since in JavaScript you wouldn't know the type of a class anyway. Right. Another example of class decorator, and this is maybe more interesting, you can actually access class prototype in a class decorator and modify every single method, for example, in that class. And this is what I did here. So basically, I took a class, I iterated over its prototype methods and replaced them with a different definition that adds additional logging logic on top of it. So you can imagine that you could write class decorators that replace the need for many lines of code in your program, which would make it more readable and less error prone. Yeah, that's cool. Another type is property decorator. Property decorator can only be used to observe or add additional information about a property. Property decorator receives two arguments, which is a target, that is a class definition, class reference, a property key, which is a property name, and there are actually difference between JavaScript and TypeScript decorators in a way that JavaScript decorator would also receive an additional property descriptor. Right. Property decorators can only be used, as I mentioned, to add additional information or observe that property, and they are not that interesting by themselves. But I still thought that I need to make a valid example of how could you use them. So, for example, here I created a decorator that takes a format string, which is additional information, and assigns it to that property by using class prototype. And yeah, you can see that later you can access that additional information in a print method where you can apply it in your logic. And yeah, once again, I will mention that in my opinion, there isn't much use of a property decorator without reflection and metadata, which I will talk about a little later. Then there's Accessor Decorator. Similar to property decorator, as I mentioned, it can be used to add additional information about that property. It actually receives three arguments: a target, which is a class definition, a property key, which is a property name, and a property descriptor, accessor property descriptor, which can be actually used to modify the behavior of a getter and setter. Yeah. And another thing to point out is that since getter and setter of the same property is actually kind of the same property, they share the property descriptor. That's why there's a limitation that you can only decorate either the getter of the same property with a single decorator. Yeah, and I've created an example here of Accessor Decorator, which adds additional logging logic on getter and set methods by using a property descriptor to replace the get and set methods with a version of those methods that have that additional logging logic. Yep. Then there's this one of the more interesting decorators, the method decorator. You can, as I've already mentioned, you can use method decorator to replace the logic of a method, and that's done in a similar fashion like I showed you with Accessor Decorator, where you use a property descriptor and access value property of that property descriptor object and replace it with a different implementation of a method. Right. So I thought that there could be a more interesting example with method decorators. So I created this. Imagine that you have a business logic that throws some business-related errors, but at the same time, you need to expose HTTP errors. However, you need to transform those errors to appropriate HTTP serialized errors. For example, it should have probably a status, a message, and something like that. And you wouldn't want to expose a stack trace or something like that. So you could create a switch error decorator, which takes one error and another error as an arguments, actually error types, and wraps the method in a original method in a try-catch block and calls the original method. And in case of an error, it checks whether the error matches the instance of a given type. And if it is the case, it would transform it to that to type error. And this way you could do something like this, where you write your business logic, you throw business-related errors, and transform them to appropriate HTTP errors. Let's get to the parameter decorator. Parameter decorator, as I've already mentioned, is only available in TypeScript now. It receives 3 arguments: target, which is a class definition, class reference, property key, which would be the method name that the parameter decorator is used, and the parameter index, which would be the index of the argument in the method. Right. So you can actually, and this is one of those examples that you can actually combine decorators, and even though, for example, parameter decorators or accessor decorators aren't interesting by themselves, you can achieve interesting results by combining them with, for example, method decorator. So in this case, I've created a parameter decorator which basically just assigns additional information about that parameter using the class reference. And later I can access that information in a method decorator which wraps around the original method that I decorate and checks whether the given argument is null or not. And in case if it's null, it can throw an error. So it can result in something like this. And as you can see in the example on the right, where you could write clean and simply to understand validation logic. Right. I've showed you some examples of how can you write your own decorators and what can you do with them. I showed you that you can combine decorators to achieve some interesting things, but let's talk about what's already available. So decorator feature is quite popular actually, and it's already widely adopted by some libraries and frameworks. For example, TypeScript and Nest.js are full-featured application frameworks that are built around decorators. There's also Angular, a front-end framework which uses decorators. And there are quite a few libraries like Class Validator for validation, TypeDI for dependency injection, and so on. So in summary, you can actually find already written libraries for most of your use cases. So you could easily use decorators in your projects right now. And here's a couple of examples of how those libraries and their decorators look like. As you can probably notice that, for example, TypeScript and Nest.js are quite similar. And Class Validator gives you ability to decorate your class properties and validate them. And yeah, TypeDI, for example, gives an easy way to create dependency injection. I will show you one more example, but before that, I need to explain a few more concepts. And those concepts are reflection and metadata. These are quite complex topics, and you could probably make a talk just about them, but I'll try to explain it to the best of my ability. So I would explain reflection as a programming language ability to intercept, inspect, and modify behavior of a code in the runtime, and metadata as data which is associated with that code. And combining these two concepts, you can achieve something which is called metaprogramming, which is a very powerful technique where basically computer program can change itself in runtime. Yeah, an interesting fact, actually reflection was natively available in assembly language right from the beginning, and later it was lost with the introduction of C language, and then later introduced with more higher level languages again. So JavaScript has this reflection API already available today, and it provides method that allows you to intercept JavaScript operations. I hope you can see it. I wanted to fit everything in a single slide, so I had to shrink down the text, but I hope that you can see it. But anyway, reflection API allows development of programs and frameworks and handle code dynamically. Right. And metadata. Metadata is actually another proposed feature like decorators, and it's not natively available today. And it adds on top of the reflection API by providing additional methods to work with metadata. And it also, the proposal also suggests that the actual every single object in JavaScript should be extended with metadata property and metadata methods. Right. So this is my more advanced example. I try to keep it simple, but basically I've created an inject decorator, which will take a key, and I will be using it to decorate a constructor parameter and assign additional information about that parameter using reflection API. And later, I will be accessing that information in a container, which is basically just a class with a couple of methods, and that contains a list of, actually a map of dependencies. So by using inject method, I push that dependency into the container, and by using resolve method, iterating over those dynamically assigned properties about that parameter, and try to resolve the dependencies like that. This is really simple example, and you should probably do some validation and checking whether the type matches, etc. But this shows that you could easily achieve dependency injection with decorators, and it would look really clean in actual code usage. So yeah. So this is sort of end of my presentation regarding decorators. However, there's still one topic that I need to talk about because decorator feature depends on it. And this is ECMA and TC 3090, which stands for European Computer Manufacturers Association, and Technical Committee 39, which is a working group of ECMA organization. So ECMA organization is an organization which standardizes IT systems, and one of those standards is JavaScript, which the TC39 group is responsible for maintaining and evolving. So, and features like decorators and metadata that want to be added to the language need to go through these 5 stages of official process. So first stage is stage 0, which is just an idea that gets suggested to the working group. And if the idea is good, a formal proposal is formed, and it reaches stage 1. At this point, a group is formed, a group of people is formed, and a leading person is assigned. Usually the leading person is the same person that suggested the idea. After that, they start developing their proposal. And and once they're done with that, once they document everything, implement everything, make tests, example implementation, it reaches draft stage. And after the testing and sort of a cool down time, if everything is working fine and there's nothing that needs to be added, it reaches stage 3, which is candidate, basically a release candidate. And at this point, it's safe to say that the feature is going to be released at some point in the future. Actually, it should be said soon in the future. Yeah, and then the stage 4, which basically means that the feature is done and it can be started to implement in languages like actually language engines like V8 and etc. So, and I've marked these stages in a red and green zones. And that's to emphasize that actually, while the feature is in the red zone, it's an experimental feature, and it doesn't mean that the feature. It doesn't actually mean that the feature will eventually be released. It might as well get canceled. So, why am I talking about this? That's because it happened, and every single example that I showed you in the Decorator API is not going to see the day of light. Yeah, so they changed the standard, and no worries, it's all for the better. And the legacy proposal, which I showed you the examples, is still recommended, since there are actually no way to test the next proposal version, as there are no transpilers that can do that today. So yeah, and another interesting thing about this new proposal, if you look at the API, it has get metadata, set metadata methods. And as I've mentioned that, for example, in case of parameter decorators and property decorators, there isn't much that you can do with them, and you do need to use metadata to assign additional information about them. This version of API has methods built in for that. So let's speculate what can happen in the future. So since the reflect metadata proposal is really tied to the decorators, I would assume that it will be released first, or it's going to be released together. There's another concept that is in the works, which is called decorator extensions. And for example, like I mentioned, parameter decorators, which are not yet available in the JavaScript, it could be by using extensions. And actually, TypeScript has plans to implement this new Decorator API in their roadmap. So we should probably see this new API available to play around with in TypeScript probably next year. And taking into account how many libraries have been built around it, how much time companies like Google invested with their Angular framework, and how people are adopting decorators, I would bet that it's going to be released anyway. So, yeah, any questions?
Okay, well, thanks a lot for your presentation, and for sure we have some questions. So, first one, a little bit theoretical. So, how to become a tech lead? which should be something interesting for you, since not sure if everyone knows, but Antanas here is our brand new Node.js team tech lead.
I guess you just have to be interested in what you do. I mean, that's basically it, I guess. If you're really interested, it doesn't actually mean anything when if you become a tech lead. You just love what you do.
All right. Best wishes. I hope you will enjoy this role. Right. Are decorators often used in telesofts, and which methods are the most popular?
Yes and no. I mean, we have a project that we heavily use decorators there because we actually use the Nest.js application framework. So yeah, we use it heavily. Although we try to keep it within, I mean, common sense. And for example, we don't use decorators in our business logic. But yeah, we do use them, even though they are considered experimental. Well, not considered, they are experimental.
Yeah, no. Yeah, from
We're on that kind of bleeding edge.
Yeah. Right. Last one, Fastify or Express, more commonly used under the hood with Nest.js by Team Telesoftas?
Actually, for now, we're using Express, but we are considering switching to Fastify. And it actually, by using something like Nest.js, it shouldn't be a problem. I mean, just a couple of, just change the packages, and that's kind of it.
And which one would you prefer?
I guess I would, if I had to choose, I would probably prefer Fastify.
Fair enough. Okay. Last question for a cooldown. Do you rap when you are not coding?
No. No.
All right. Thanks a lot for the presentation.